Right? Graphing cosine functions. So fill in the table similar to what we did with the sine functions. And we have our 5 critical points in it. In this case, we have 0, 1, pi over 2, 0, pi negative 1, 3 pi over 2, 0, and 2 pi 1. So if we plot those critical points, and we can draw our graph. Notice it is a curve, it's not a V. So if you graph it on your calculator, you will also see that it is continuous, with the domain still being negative infinity to infinity, and our range being negative 1 to 1. Okay? Other important information we need to know would be that both graphs that we've done cover a period of 2 pi. That's why we're gone from 0 to 2 pi. That is a complete cycle. Notice when we do it in the calculator that it keeps going when going through multiple periods. Also note that the sine function is odd and the cosine function is even. So now let's take a look at a couple of transformations in terms of up, down, and how the amplitude impacts it. So again, we plot the points for our parent function of cosine. So here, here, too far, pi negative 1, 3 pi 0, and 2 pi 1. Erase step. So those are the points of our parent graph. You can draw that. So the domain again is negative infinity to infinity, and the range negative 1 to 1. So if we're graphing 2 times the cosine of x, the domain is not going to change. It's still going to be negative infinity to infinity. But we have a stretch. So now instead of starting at 0, 1, we're going to start at 0, 2. The pi over 2, 0 will remain. Instead of being at pi negative 1, we'll be at pi negative 2. 3 pi over 2, 0 doesn't change. And 2 pi 1 now becomes 2 pi 2, because 1 times 2 is 2. So here's our graph. So the range is now negative 2 to 2. So pause the video now. Take a moment, graph 1/2 cosine x, and press play when you're ready to continue. Okay, notice again how the red 2 cosine x is a stretch, and the green 1/2 cosine x is a compression. So the domains don't change, but the ranges are altered. Okay, now let's take a look at what happens with the direction change. So again, let's start with our parent graph. So, if we're going to do a direction change, instead of starting at 1, it's reflective across the x-axis, now we're at negative 1. We're still at pi over 2, 0. Now, instead of being at pi negative 1, we have pi 1. That point doesn't change, and 2 pi, now again we're at negative 1. So instead of opening up our graph now, we'll open down. So So the domain, again, is not changing, but the range is also not changing. It's not impacted by the direction change. So, similar to cosine, similar to sine, excuse me, the direction change does not impact the domain or the range. Okay, we have two practice problems here. Pause the video, try them on your own, and press play when you're ready to continue. So if we look at the first graph, we have a stretch of 3. So notice the points that are actually on the x-axis, here and here, they are not impacted. Only the other points are impacted. So now, pause the video and try -2 cosine x if you haven't already done so. Press play when you're ready to continue. All right, so in the second graph, notice the direction change and the stretch. Again, the points that are actually on the x-axis, here and here, are not impacted. So now let's take a look at our vertical shape. We have the cosine of x minus 1. We've already graphed the parent graph here in black, so we're going to move all the points down 1 because of the minus 1. So the domain and range remains, or the domain remains the same. Now, the range, instead of being -1 to 1, is -2 to 0. Okay, because here's the top. Alright, so pause the video, try graphing cosine of x plus 1, and press play when you are ready to continue. Okay. Notice the graph in green of y is equal to the cosine of x plus 1. All the points were elevated 1. So now we have a range with the bottom being 0 and the top being 2. So let's practice some more on your own. Do the following graphs, press pause, do the graphs, and then press play when you're ready to continue. Okay, notice the points in black are those of the parent graph, which is why it's cosine x. So if we do the reflection first in blue, we will go from 0, 1 to 0, -1. That remains on the x-axis. This goes from pi -1 to pi 1. That stays on the x-axis, and instead of 2 pi, 1 goes to 2 pi -1. So there are the points with the reflection. Now the vertical shift down 3 means we're going to move all our points down first. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. So there's the graph of negative cosine x minus 3. So if you haven't already done so, press pause and graph -3 cosine x plus 1. And press play when you're ready to continue. Okay, again, the blue points indicate the direction change. Then we have a stretch of 3 and bumping everything up 1. So the blue points indicate the direction change and the stretch. And then the red shows what it looks like after you add 1. Okay. So complete the attached worksheet and let me know if you have any questions next time you see it.